This lesson is going to introduce us to the oxidation of food and will mainly focus on aldehydes and ketones. These are the learning outcomes that are going to be covered in this video. When food is exposed to air, many of the chemicals in food react with oxygen and the food is spoiled. So if you cut an apple in half, the surface will react with oxygen and go brown. Edible oils and fats, such as butter, turn rancid on long exposure to air, as oxygen reacts with the unsaturated parts of fats and oils, turning them into foul-smelling molecules with an unpleasant odour. The chemicals in food undergo oxidation reactions on exposure to air. Oxygen from the air causes the oxidation of food, so if edible oils have been oxidized, they'll have a rancid flavour. Many foods, such as salads or crisps, are packaged in an unreactive inert gas, such as nitrogen, to help prevent oxidation. Later in the unit, we're going to look at some oxidation reactions involving carbon compounds. Before we do that, I want to introduce aldehydes and ketones to you first. Aldehydes and ketones are molecules containing a carbonyl functional group, i.e. carbon that forms a double bond with an oxygen. On the left is a molecule called propanal, which is an example of an aldehyde. You can see it's got the carbonyl group here, i.e. a carbon forms a double bond with an oxygen. On the right, we have a molecule called propanone, which is an example of a ketone. In the middle of the molecule, you can see the carbonyl group there. So these molecules, aldehydes and ketones, both contain a carbonyl functional group, which looks like this. We're going to have a quick look at aldehydes first. The simplest members of the aldehyde series are methanol and ethanol. So methanol contains one carbon. You can see it's got a carbonyl group. Methanol is also known as formaldehyde, which is used for preserving biological specimens. So if you collected a sample of a biological specimen and you don't want it to rot, methanol is very good at preserving it. Ethanol contains two carbons with a carbonyl group, and it's produced in the liver when ethanol is broken down. And it's the ethanol that contributes to the symptoms of a hangover. The thing to note is the functional group of aldehydes is a C double bond O with an H attached, and these are always at the end of the molecule. Aldehydes can be identified by their al ending. If you're naming a straight chain aldehyde, the first thing to do is look for the longest chain of carbons, and that will give you the prefix, i.e. the first part of the molecule. So for instance, in the molecule shown below, the longest chain of carbons is 4, so it's going to be called butanal. Notice we've got the shortened structural formula to the right and the full structural formula here. Another thing to note about the shortened structural formula is it ends CHO rather than COH. The reason for this is because COH would give a false impression that there's a hydroxyl group present in the aldehyde, when there's not. It's a C double bond OH. When naming branched aldehydes, the first thing to do is find the carbonyl group and assign it a number of 1. Then count the number of carbons in the longest chain. So in the molecule shown below, you can see we've given the carbonyl group a number of 1, and our longest chain has got 5 carbons, so the parent name for this aldehyde is pentanal. You'll notice that we've got a methyl group on carbon number 3, so therefore the name of the molecule is called 3-methyl-pentanal. One thing to note, that a number is not used to indicate the position of the aldehyde or carbonyl group, since it is always at the end of the molecule. Ketones can usually be identified by their own ending. So the simplest members of the ketone series are shown here, which are propanone and butanone. Propanone has got 3 carbons with a carbonyl group in the middle carbon and is found in nail varnish remover and is used in the making of perspex. Butanone has got 4 carbons and is mainly used as a solvent in industrial processes. The functional group of a ketone is shown here. Note that we've got a carbonyl group, and the carbon in the carbonyl group is joined to a carbon on either side of that carbon. To name straight chain ketones, you need to find the longest chain of carbons and put -one at the end. So this straight chain ketone has 5 carbons in its longest chain and is given the name pentanone. More information needs to be put into that name though to tell us what the carbonyl group is. So you look to see which end the carbonyl group is nearer. You can see in this one it's nearer the right hand side. So we'd give that a number 2 rather than 4. So our name of this molecule, because the carbonyl group is in carbon number 2, is pentan-2-one. When naming branched ketones, the first thing to do is look for the longest chain of carbons in the molecule. In the molecule shown here, we have 6 carbons in the chain, so the parent name is hexanone. The carbonyl group is nearer the left-hand side, so we would give it a number 2. So we'd call this hexan-2-one. However, we have a methyl group at carbon number 4, so this would be 4-methyl hexan-2-one. Note that the carbonyl group will determine the numbering of the molecule rather than the methyl group. Here are 3 aldehydes. What I'd like you to do is pause the video and write down what you think the names of these 3 molecules are. Okay, the first one is 4-methylpentanol. The second one is 2-methylhexanol. And the third one is 2,3-dimethylbutanol. Here are 3 ketones, so pause the video and see if you can get what the names of these molecules are. The first one is called pentan-3-one. The second one is 3-methylpentan-2-one. The third one is 4,4-dimethylhexan-2-one. As well as naming aldehydes and ketones, whether they're straight chain or branched, you will need to be able to draw the structural formula of them too. Here are 4 examples for you to try, so pause the video and draw the structural formula of the molecule shown. So here is the structural formula for propanol, 3-methylbutanol, heptan-2-one, and 2-methylhexan-3-one. The reason aldehydes and ketones are part of the oxidation of food course is that many flavour and aroma molecules are aldehydes. So these graphics have been taken from the Compound Interest website by Andy Brunning, which has some fantastic resources for chemistry. So you can see that in terms of the aroma of frying bacon, 31% of the volatile molecules that come from bacon are aldehydes. And in terms of the smell of chocolate, you can see that some aldehydes such as 3-methylbutanol contribute to the aroma and taste of chocolate. This is another graphic from the Compound Interest website showing that various forms of hexenal can contribute to a cut grass smell that you get from freshly cut grass. Here is an exam question for you to try, so pause the video and see what you think the correct answer is. Well, the longest chain is 5 carbons, so it's going to be pentanone because it's got this carbonyl group between 2 carbons. The carbonyl group is nearer the right hand side, so we're going to give this a number of 2. This has a methyl group at carbon number 3 and a carbon number 4, so the name of this is 3,4-dimethylpentan-2-one. Here's a past paper question I want you to try, so pause the video and see if you can get the correct answer. So if you look at the molecule and try and find the functional group, I'll just show in a box here. So what group could this be? Well, it's not an ester, that's shown here. It's not an aldehyde, that's a carbonyl group with an H at the end of a molecule. And it's not a carboxylic acid. So the functional group is a ketone because it's a carbonyl group flanked either side by 2 carbons. So our correct answer is B, a ketone. This exam question is testing that you know your functional group, so pause the video and see if you get the correct answer. Okay, so the functional group we see circled here is a carbonyl group. In addition to that, we've got 3 hydroxyl groups. So our correct answer is C. Okay, here's another one testing that you know which functional groups are present in aldehydes and ketones and fats and oils. So pause it and have a go. Okay, well, aldehydes and ketones, I've shown propanol and propanone as an example, have a carbonyl group. So it's either going to be A or D. If you look at a section of a fat, you'll always notice there are 3 ester links attached to a glycerol. So we've got the ester link as the answer for fats and oils. So our correct answer for this is D. So this is a summary of the outcomes covered in the video. Make sure you have a good knowledge of aldehydes and ketones because you will come across these again in oxidation reactions later in the unit.